and let's understand what sampling is all about. Because again, like I said, if you don't understand sampling, it's impossible to understand what weights are and why we use them. So today's session will be hands-on. So I have a task here. We're going to do it together. And hopefully by the end of the session, we should have a solid grasp of what weights are and how they are related to sampling. So I have okay, this task here. So we have a Lungi, can you confirm you can see my screen clearly?
Yes, we can, sir.
All right, super. All right, so we have this task we're going to do together. This is a hypothetical kingdom, the kingdom of Zamunda. You have been hired as a consultant to conduct a national survey for this country. The country has a total of 10 chiefdoms. Chiefdoms are like, smaller areas in the country. And the chiefdoms will be used as clusters for sampling. And so this is the kingdom here of Zamunda here, right? So these are the chiefdoms. So in each of these tabs, each of them represent a chiefdom, right? So we just pretend that when this is a country and you can think of the chiefdoms like clusters or local government areas, but we're calling them chiefdoms here. There are 10 of them. Let's go back to the task. So the task continues that the last tab titled combined represents the pooled data from all of the 10 individual chiefdoms. So here we have the last, let me move this out of the way. The combined. So this is the combined. This is all of the chiefdoms put together into one single data frame. So that's what we have there. Each row in each tab represents one individual. And the column for metabolite X represents the individual level outcome of the biomarker measured for that individual. So in each of the chiefdoms, we have data collected on, we have like some registry data or some population level data on each individual. You have the unique ID, you have the name of the individual, you have the zip code, and then you have the hospital that they attended for care. And while at the hospital, they took their blood level and measured the concentration of this metabolite we're calling metabolite X. The goal of the research is to find the average levels of metabolite X in the entire kingdom, in the entire country. So again, we have one country with 10 chiefdoms or local government areas. The goal is to use different types of sampling to generate a representative sample that will give us an estimate of the mean levels of metabolite X. All right, so our tasks are below here. So this is the sampling frame. Let me share this link with everybody so you guys can access it. And I also share the spreadsheet here so we can work on it collaboratively. I'm going to need some people to help us with some of the tasks so that we can, how do I share this again? File. I may have to refresh this just a minute. Oh, share right here. All right, let's share it, try again. So copy link. And let me drop it in the chat. So it's going to be very hands-on. Like I said, I'm going to need volunteers to help with these different tasks so that we can have a hands-on. Where's the message? Okay, right here. All right, so this is the spreadsheet that contains all of this information. And then let me share this as well. Let me just copy this part. Okay. I want to keep it simple, so let's just copy what we need. And create a new sheet. All right, let's share this document. Let's call it sampling task for Samunda. Yeah, let's make people editors, viewers only. All right, so you have the access the document and the spreadsheet. So here is what we're going to do. We have this table we're going to collectively fill together. We are tasked with calculating the mean levels of metabolite X with different sampling strategies. So this blue column means that we're supposed to sample with systematic sampling. And we're going to draw different sample sizes. So for here, we're going to draw sample size of 100, and then for 1,000, then 10,000, then 20,000. And so this blue column is where we're going to fill the values of these cells based on systematic sampling. The second column will be based on simple random sampling. And then the third set of columns will be based on different types of cluster sampling. We're going to do a single stage cluster sampling with simple random selection. We're going to do a single stage cluster sampling with systematic selection. We're going to do a two-stage PPS sampling. If that sounds like Latin to you, that's fine. By the end of the class, that you should become quite proficient with all of that. And then we're going to lastly do a stratified two-stage cluster sampling. All right, so let's first of all focus on this first set of columns. So for systematic sampling, what we're going to do is we will go back to our, so in this case, we're saying take the entire combined data set and do systematic sampling. Systematic sampling is the kind of sampling where we first of all sort a data set by a characteristic. The characteristic we're sorting on must be something that is highly correlated with the outcome of interest. So here, our outcome of interest is the mean levels of metabolite X. So the question is, what do we sort on? Whatever we're going to sort the data set on must be something that is highly correlated with metabolite X. So we can argue that maybe the place you live is highly correlated with your blood levels of metabolite X. Maybe you live in an area where there is environmental, contamination, and so your levels of metabolite X might be very high. The bottom line is that whenever you're doing systematic sampling, whatever you choose to sample on must be highly correlated with the levels, with whatever the outcome is. So here we have the data set here. We can't sort on name because names are very arbitrary. There's no correlation between sorting on names. You might say, okay, let's sort names in alphabetical order, and then let's select by name. That makes no sense because there's no correlation between individuals' names and the levels of metabolite X. You might say, okay, so in this case, in this data set we have, why is this thing hanging? The only variable that we have would really be the levels, the zip code where they live. You might have, let's say, their shoe size. It will make no sense to sort on their shoe size because theoretically, why do you believe there's a correlation between their shoe size and the levels of metabolite X? So the bottom line with systematic sampling is that you must sort on the variable that is highly correlated with the outcome. Systematic sampling is the only sampling type that is affected by the order of sampling or by what you sample on. So that is the distinguishing feature of systematic sampling. Systematic sampling is also a sampling technique that could be both random and non-random, depending on how we selected the first item. Again, you don't have to ever do this thing manually. Well, we are going to do this, on the Chisquares platform automatically, but this is just so we establish some of the theoretical basis of some of these things. So, so we need 5 volunteers to help because we have 5. We have 5 cells. We have to fill 1, 2, 3, 4. Okay, 4. So we need 3 volunteers to assist us with doing the systematic selection for the other 3. We're going to do it together. I'm going to do for this one, and then you will do for the other one simultaneously, so that we save time. So who wants to volunteer? Lungile, can you select 3 volunteers for us, please? So we just do step by step, and then as I fill in the value for this, you'll also fill in the values for the other ones that you are responsible for. you should be savvy with Excel before you volunteer. So you should be someone who has some basic knowledge of using Excel. All right, so any volunteers?
Please raise your hands. Let's see.
You don't have to know how to do it. We're going to walk through it together. So prior knowledge of it should not be a requirement for raising your hand. We're going to do it together.
Okay, we have 2. Charles. Okay, we have 3.
All right, super.
Thank you.
So you have access to the spreadsheet. So what we're going to need now is we're going to use a combined, all of Zamunda. So you can either copy or download. To copy all of the data, just if you shift command and the arrow down. So if you want to copy everything in Excel, click on the first cell at the top, then press Command Shift, and then the right arrow to select everything to the right, or the down arrow, select everything down. You don't want to drag and start. This is a lot of cells. You don't want to just keep dragging. That will take you forever. So I will then copy this and take it to my Excel spreadsheets. So paste it there. Or you can simply, if you don't want to do that, you can simply download it directly too. That's up to you. So I'm downloading the data. I'm pasting the data. It might just be faster for you to just download it directly from the Google document. Because if it's a large file, it might take you time. But I just wanted to demonstrate different ways you could do it. Maybe this was a bad way. This is going to take me a while now. Are you guys following along?
Yes, we've copied already.
All right,
Yes.
super. All right, so
must it be Google Sheet, or can I use just the normal Excel?
In the same town.
No, you are going to copy the data from the data is in Google Docs, Google Sheets, right? So you're going to copy it to your own Excel on your machine, on your computer.
So that's yes, Prof. What I ask is, I will need to put it in Google Sheets or normal Excel, like
normal Excel is
Microsoft
fine.
Excel.
Microsoft Excel
Okay,
is
fine. Okay, fine.
So somebody said we should reiterate the copying command. To copy, Command Shift, left or right, then whichever direction you want to go, whichever direction you want to copy everything. So Command Shift, if I want to copy everything down, I'll press the down arrow. If I want to copy everything to right, I'll press to the right, the arrow to the right. If I'm from here, so you just press Command Shift. If I'm here and I want to copy everything, I can press Command Shift down and right. So it selects everything in the direction I want. So I have the data here. So let's go ahead and save this. So File, Save As. You can save it whatever name you want. So let me save, let's call this, I'll call this systematic sampling. So I've saved my file. It's now systematic sampling. So the task required us to, first of all, calculate the mean levels of metabolite X based on systematic sampling. So let me know when you guys have done that. All right, super. Thank you. Now we'll go to the Chisquares platform and we'll initiate sampling there. So let's so I'm gonna log in, and you'd go to sampling, and start new sampling. In this case, since we are uploading our own spreadsheet to sample from, make sure you select perform probability sampling on a sampling frame. A sampling frame is just a fancy term for an Excel spreadsheet that has all the data inside it. So select probability sampling on a sampling frame. Give me a thumbs up if you are at that stage.
Sorry, Prof. So I'll go to sampling and
Yeah,
upload.
go to sampling, then select say sampling frame option, the second option. Perform probability sampling on the sampling frame. Are you winning?
Yes, trying to upload now.
Oh, okay, all right. Yeah, okay, you even had ahead of me. All right, so let me upload my systematic sampling. Okay, you should get a success notification if it's uploaded successfully. Let me know when you're there. All right, super. Then next step is we have to select sampling approach. We're going to select systematic sampling. Select a unique identifier. That's optional. We don't need that. But the second is very important. Select sorting variable. Systematic sampling is the only type of sampling where you'd have to select a sorting variable. It is the only sampling type affected by sampling, by how we sort. So you must select. Yes, Charles, you have a question.
So the other option, you say we don't need it. I will leave it. We are going to leave it on that select, just
Select
on
an
the
option.
default, which is select an option. We just leave it like that.
Yeah. But in this case,
Okay.
but if you want a unique identifier, in our data set, it's actually called unique ID. We actually have
Okay.
unique identifier, but it's not in every case that you would have a unique identifier.
Okay. So we'll just leave it at that default, which is select an option.
Exactly. But if you want,
for
you
this
can go ahead
particular.
and, yes. But if you want, you can go ahead and select unique ID.
Okay.
But in my case, I typically will leave it blank because most of the time you will not have a unique ID anyway. So then next, select sorting variable. The sorting variable here is we're using zip code to sort the data on, because our argument is that where you live is highly correlated with your blood levels of metabolite X. Remember that whatever you're using as the sorting variable must be highly correlated with the outcome of interest. And the next thing is, how many people do we want to sample? Now, in my own case, for my own task, I was asked to sample 100 people. You will select the number you have. So mine is 100. So I'll select 100. So there are 29,000. The platform tells me that in my spreadsheet, there are 29,769 rows. And I have to select 100. Yes, Charles, you have a question.
Yes, as when I picked when I went to the option of select sorting variable, I'm only seeing unnamed unnamed 0 unnamed. That's the only option I'm seeing.
You have to go back to your data set that you copied.
Okay.
You have to make sure you have column names at the top. You have column names at the top.
Okay. It seems this is a data set. It seems what I copied was not even this.
Okay, so you have to make sure that that's what you copied.
Yes, I'll do it quickly now. I'll do that one very quickly. Just go ahead. I'll do that one. I'll join up.
Okay, that's fine. So select 100. The other folks are
Can I select 1,000?
You have to select what your task was. My task was 100. So
that means I'll do 1,000.
Okay, Ali, you do 1,000. Who is taking 10,000? We need one person. We have 4 of them, so we need one person to take each of them. Charles, will you take 10,000, please?
Yes, I will take 10,000. Let me just upload. I will take 10,000.
Okay, so we need one more person. I thought we had 3 volunteers. Who is the 4th person? They should take 20,000. Arinze, you are the 4th person, right? Okay. So let's start from the beginning so that we're all on the same page. So the first stage was that we have this is our total population. This is everybody who lives in the kingdom of Zamunda, right? There are 29,000 people in that country. So we have all of them in this spreadsheet. This is the unit ID.
Prof,
Yes.
sorry. So we have some people who are lost, perhaps. I don't know if it's because they don't know about the platform, or perhaps you can just start by telling us how to get to the Chisquares platform.
Okay, sure. So the Chisquares platform is a research platform that allows you to do anything related to research. You can access it by going to www.chisquares.com. So let's first address that, and then you log in. If you don't have an account, Lungile, you can please share the link for folks to be able to get an account, create an account. So you have to create an account. If you don't have an account, you obviously cannot use the platform. If you have an account, you log in. So that's where that solves that part of the question. The second part of the question is, where are we getting the data we are using? Where is this data coming from? This is just mock data that I created. It's just mock. It's not a real data set. We just created this for the sake of learning, right? And the link to that has been shared with you. This is the link to the data set here, which I'm copying and sharing with you. So that's the data set there. Now, the next part of it is, what in the world are we doing? Well, what we're doing is that we are given a task here. We're told that we have to calculate, we have to do a study to find the mean levels of metabolite X. Metabolite X is just a made up stuff, right? Whatever it is, doesn't really matter. It could be mean levels of calcium, mean levels of whatever it is, doesn't really matter. The point is, how do we apply different sampling techniques to answer a research question? And in this case, we've been given a task that we should fill this table with different types of sampling approaches. So the blue one says, fill these columns with systematic sampling and do that with different sample sizes. Sample size 100, 1,000, 10,000, 20,000. And we're supposed to draw a sample from that. Lungile, I'm not sure why I'm echoing in your device, but we're supposed to draw a sample from here and from that parent population and calculate the mean levels of metabolite X and fill it based on this sample sizes. I don't know whether we're all clear now. If anyone has a question, please ask. The
Chisquares. Okay.
It's a web platform. That means that you have to be on the web to use it. So, Yusuf, you say you see you're not clear. What's your question? Okay, all right, super. All right, so we're all good. So now we're now going through the process of how do you draw a systematic sample. And we said that systematic sample is a sample technique where you must first of all sort your data sets by a variable, one variable, not two, one. And the variable you select must be something that is very correlated with your outcome. That is the only thing we ask that must be met. Sort the data set first, but you're not even doing it manually yourself. You're going to do that. The platform will do all of that for you. So all you have to do is make sure you supply a variable that will be used for sorting. So what we have done is we have taken our data set here, we have saved it on our machine, on our computer, local device, and we're going to import that into the platform so that we can then implement systematic sampling. I hope we're all on the same page now.
Someone's asking which sheet name are we using to upload?
So for this one, for the we're going to use the combine. This is all systematic sampling. We're doing a systematic sampling, in this case, for all the entire population. So you're going to use the combined, all of Zamunda, the last, second to last sheet there. So these are the different tabs represent the different counties or local government areas in Zamunda. But for systematic sampling, we're going to use all of Zamunda. That's what we're doing now. Are we all good now?
That wasn't what I used. I used the first one, but let me change this quickly too. No issues.
Okay, so we're going to use all of Zamunda because the goal is, the question says, draw a systematic sample for all of Zamunda with different sample sizes, 100, 1,000, 10,000, and so on and so forth. So let's all select all of Zamunda, copy all of it. Again, to copy it, it's simple. You simply click at the very top, Command, Shift, right and down will select everything. Then Control C will copy, and then Control V will paste it in your Excel spreadsheet. Are we good? Are there any other further questions, Longile?
Are the sample sizes arbitrarily chosen?
For the sake of this learning activity, yes, we just chose them arbitrarily, but ideally you should have calculated sample size for your study. You shouldn't choose sample size for your study arbitrarily, right? But what we're trying to demonstrate here also is that sample size does not affect validity, but those are the things that we actually want to infer after we do the task, right? We want to show that when you do, random sampling, sample size doesn't affect validity at all. So that's also part of what we want to learn, right? And we can only make those inferences after we have done the task. But so yes, in a nutshell, this was chosen arbitrarily. But in your own study, you should obviously calculate the sample size.
Okay, so someone has just signed up and they don't know where to go.
Sign up
on the platform.
So if you just sign on the platform, so if you sign up, what you see is you see an empty, obviously you don't have any project yet, so everything here will be empty. What you should do is go to sampling. That's where we're working with. Click on sampling, and you don't have any history or anything, so this will be blank, but that's completely fine. Then click on start new sampling. Then click on the option to say perform probability sampling on a sampling frame. Again, the sampling frame is just a fancy word for an Excel spreadsheet that contains the elements you want to sample from. So that's what you want to select. And then you upload the spreadsheet. And then you select the type of sampling you want to do, which in our case is systematic sampling. Any other questions?
Yes, Miss. Does it allow for order? Sorry, I just joined. Am I to drop the question on the group in the chat?
You can ask your question. What's your question?
Yeah, does it allow for other sampling approaches like stratified?
Yeah, we're going to do that. But for now, we're just focusing on systematic sampling.
Okay, thank you.
Are we all good?
Okay, someone's asking you to start over.
Start over from which part?
Obi, can you clarify?
Please, hello?
Yes, Olainka.
Yeah, please, after speaking, selecting systematic sampling, there's still another option, although it's say optional. Select a unique identifier. I don't know whether we still need to select that or not.
It's optional, so you don't have to select it.
Okay, then select sorting variable. Which one?
Yes.
The sorting variable.
In our research question, I have selected zip code, but you as the investigator, you must know what, because you're going to have your own sampling frame that's not going to look like this. It's your job to know what a sorting variable is.
Okay.
So it's not you. It's not that you will send a question to Chi-Squares and say, "What is my sorting variable?" Like, okay, you are the researcher, so you have to know what your sorting variable again. And we said that the sorting variable must be a variable that is very correlated with the outcome of interest, right? If you are doing research, for example, looking at survival in a hospital setting, like or some indicator of maybe some backup. Maybe you want to look at the length of stay in the hospital, the length of hospitalization. That might be a good proxy, right? Or maybe their white blood cell count, all right? It has to be something that is highly correlated with the outcome, because that's the whole premise on which systematic sampling is based.
Okay, thank you.
Welcome. All right. So our team, do you have everything all set up now?
Yeah.
Okay. All right. So I'm selecting 100, and then I'll click on get sample. So what the platform does is that it takes the data.
One last question. How do you get the data set into the platform?
You save it on your computer, first of all. And then after saving on your computer, you will then, so you save it on your computer, and then you click this button here that says drag and drop or choose file to upload. When you click on that, it's going to ask you where your file is. You select that file, and then you upload the file. Does that make sense? All right, so this is the systematic sample we've drawn for 100 people on the platform. One of the things you can easily see here is that the hallmark of systematic sampling is that it is an equal probability sample. If you look at the last column here, this is the probability of selection based on systematic sampling. You can see that every single individual has the exact same probability of being selected. So that is one of the moral of the story for what we were trying to showcase, that systematic sampling is one of those sampling techniques that gives you an equal. Please, can we mute ourselves? It's getting quite rowdy. Olayinka, can you kindly mute yourself, please? Thank you. So systematic sampling is one of those sampling techniques that will give you a selection probability where everybody has an exact same probability of selection. So the question is, if you are using systematic sampling, do you need to apply weight? Yes or no? If everybody has an exact same probability of selection, do you need to account for base weight or design weight? Yes or no?
No base weights, because they have equal probabilities.
Exactly. That's very correct. So any setting where you have people having exactly the same probability of selection, you do not have to worry about base weight or design weight. But might you still have to worry about non-response weight? Igbekele, since I have you on the call, what do you think?
Yes, sir, that is right. If there are differential response.
Exactly. So the fact that you're not worrying about base weight doesn't mean that you don't have to worry about non-response weight. They're very different things. But for now, let's just focus on what we're doing now. So members of my team, have you finished your own sampling?
Yes.
Yes, sir.
All right, now the last task is for us to now calculate the mean levels of metabolite X from this sample we have drawn. So let's download the sample. So you just click on download the data as an Excel spreadsheet. So it will download to your download folder, which is, here's mine. And then we can now take the average of metabolite X. So can we mute ourselves? Mohammed, I think you have some background noise. So to take the average, the Excel formula we're going to use, we're not doing anything fancy here. We're just going to do something really simple here. The Excel formula we're going to use is equals to average, Average is simply same as the mean. Click on the first item, then Command Shift down to select everything, and then close the bracket. Again, let me repeat it. Equal to, you have to first type equal to average. We don't want to just keep dragging and dragging and dragging. If you have a lot of columns, you're going to sit down there forever dragging. So to avoid that, we're just going to click on the first one, then Command Shift and down to select everything. And even if you cannot see what you're doing, just press the closing bracket. Yes, Charles, you have a question.
Yes. So where are we putting the cursor in the first instance?
It doesn't matter. Just anywhere.
Okay. Anywhere. Okay. Okay, fine.
So for my own task, I have finished my task, and my average mean level of metabolite X from my sample is 34.06. So I'm going to go back to my task and put in here 34.06. So when you guys are done, please can you enter the values for your mean? And if folks have questions, please feel free to ask now. Lungile, do we have any questions in the chat? Charles, your hand is up. Do you have a question?
Some people are still lost.
Yeah, sorry, my network, I'm back now. I'm trying to run this. So equal to
average. So
Professor, can you? Yes, some people were asking.
Prof, you said it's equal to average.
Just so this equals average.
Brackets.
Bracket open. Click at the first one. Then Command Shift, then the down arrow to select everything down. And then closing brackets. Then hit enter. I mean, if you want, you can just say equals to average, and if you just want to do things manually, you can just copy everything. You can just drag. You can just drag everything if you want it all the way to the bottom. It's the same thing, but that gets messy sometimes. Yes, Charles, your hand is up. Or is that an old hand?
Hello. I've sent the result for 1,000.
Okay. Did it? You have to type? Can you type it in the box, please? Where did you send it?
Chat.
No. Type it into the box, into the Word. Oh, let me make sure I give you edit right. Hold on a minute. I want to make sure you can edit the document. You can edit. So you are an editor now. The command shift, we're just talking about Excel. The command shift is Excel. We're just saying how to use Excel, to do what we need to do in Excel.
If his word is control for those using Microsoft.
Oh, thank you very much for that.
For me, I still can't edit.
Okay, try again.
Refresh.
Refresh.
Prof.
Yes.
Prof, say that formula again. Equal to average.
Equals bracket open, average, bracket close. So let's do it again. So equals average, bracket open, then select all the things you want to average, right? All of them. And then when you're done with selecting, then you close, and that's it.
So for my own data, I'm seeing only 3 variables.
What you are averaging is metabolite X. That is that's the research question. The research question is, what is the average level of metabolite X? So we have just drawn a sample, and we're now taking from the sample we have drawn, calculating the mean levels of metabolite X. Do you understand?
Yes, but I don't know, for any reason, I'm just only seeing 3 things here on my own data set, on the result I downloaded.
Okay, what
I
are
don't
you?
know why.
Well,
I'm seeing identifier, I'm seeing zip code, and I'm seeing PR systematic. These are the 3 things.
Okay. Okay, you're saying so you're saying this one here, right? Oh, you're saying, okay, so what you're saying is that on the Chisquares platform, you're not seeing all of these things here. You're not seeing metabolite X. Is that what you're saying?
Wait, the one I downloaded, I only saw 3. But let me go back to the platform and see if it's 4 on the platform itself. Okay, it's still 3. What I'm seeing here is 3.
So that means you didn't copy everything then in your spreadsheet.
Oh.
Yeah.
Hello, Doc.
Okay.
Yes.
Just go ahead. I'll run
Hello,
it.
Doc.
Yes.
I must get it
I've
today.
done. Hello, Doc. Good afternoon.
Hi, yes. Hi.
I've done for 20,000. I got 34.25.
All right, great. Let's put that here then. Let's update the numbers. Oh, great. We have the numbers all updated. So
Okay.
now your number may not be what this person got. And do you know why?
Unique ID might be different.
No. So what did you get for 20,000 from your own calculation?
34.25.
Okay. Okay, that's the same thing they got.
And
so maybe you're the one that typed this. So, but what I'm saying is that you might get a different number, right? And that's completely fine. That's the whole point of random samples. The reason why you might get a different number is because the random stats may be different in your case. Do you understand?
Yeah.
So the individuals selected are not the exact people in your sample versus that sample. That's why it's called a random sample. If it were the same individuals who are fetching each time, then it's no longer a random sample, right? So the whole point of this is to show you that, to demonstrate that sample size does not affect validity, right? If you draw a random sample, you're going to get about the same value every single time, regardless of sample size. So you can see here, sample size of 100, you can see the estimates are more or less the same. You see that? Right? But what will be different here will be the precision, right? So we didn't calculate confidence intervals here, but if we were to calculate confidence intervals for different samples, which one will have the smallest or the narrowest confidence interval? What do you think? If we were to calculate the confidence intervals alongside this mean estimate, which one will you expect to have the narrowest confidence interval, and which one would you expect to have the widest confidence interval?
The one for 100, we have the widest confidence interval. While the one the one with 20,000 samples, we have the closest or narrowest confidence interval.
Excellent. So the moral of the story from just comparing this stuff is, we can say that sample size, so somebody should fill in the blanks. Sample size in surveys, sample size does not affect blank, but affects blank. Who wants to fill in the blanks for us?
It doesn't affect
sample
the
size
mean.
does not affect
validity.
It does not affect estimate, but it affects precision.
Okay, yeah.
Does not affect. Okay.
Go ahead.
I wanted to say validity.
Excellent, you're right. So sample size has no bearing on validity, but has a huge bearing on precision. So you see, whether our sample size is 100 or 20,000, the estimates are more or less the same, right? So it has no impact on validity. What it affects is precision. And precision will measure that by standard errors or by the width of confidence intervals. All right, now let's go ahead and do the same thing for simple random sample. So with simple random sample, we're going to do the same thing, but instead of selecting, let's go back to resample. Instead of selecting systematic sampling here, we're going to select simple random sampling. So what you will notice is that we no longer have to select any sorting variable because the concept of sorting only applies to systematic sampling. When we're doing simple random sampling, we don't have to worry about all of those things. We just select the type of sampling and then we'll select the number we want. So I want some volunteers to help us complete those cells based on what we have done. Let's have volunteers to complete that while I take any questions from people who are still confused. Lungile, do you have any questions from any members who are still confused about any aspect of this? Please, if you have any questions, please ask them.
Timothy, do you have a question? If not, please mute yourself.
All right, we need volunteers to work on the other. I hope we have folks working on this simple random sampling for the other ones.
Yeah, I'm doing for 1,000.
All right, super. So again, if in your own study, you're not selecting the numbers arbitrarily. You have to calculate the sample size. So for your own study, you have to go so you go to the Chisquares platform and you go to sample size. So I want to answer that original question about how do we select the numbers? Are they arbitrary? No, they are not arbitrary. So you go to sample size and you click on start sample size. That's how you will know the number you need to sample, right? So you select the study type you want to do. If it's a survey, that is a cross-sectional survey, you select whether your outcome is categorical, in which case you select percentage as outcome, or mean, which is continuous. So if let's say you're looking at smoking, that's a categorical outcome. So in that case, you'd select percentage as outcome. You will then supply the different values here. The level of confidence, which is typically 95. The prevalence of the outcome, if you don't know what the prevalence is, you want to just put 50%. 50% is a value that guarantees you the maximum sample size. And in the context of uncertainty, we want the maximum just so we're covered. Whether it is, so we know that since we got the maximum, it doesn't matter what the actual prevalence was, we've gotten the maximum sample size possible. So 50% prevalence assures you that you're going to get the maximum sample size. You enter a rough estimate of population size. So this is the number of people who live in, who belong to that population in total. So if my survey is a survey of all adults in Nigeria, then maybe the population size will be around 200 million people. If my survey is a survey of doctors in Nigeria, then the population size may be maybe 500,000 or whatever the number is of people who are in that population. So this is not just some random number. Nor is it just some fixed number. It reflects the population you are studying. If your survey is a survey of some outcome among animals, let's say cows, well, then how many cows fits that population of interest? So that is what you put here. For very large populations, you don't even have to change this number. You can always leave it at 1 million because sample size is agnostic of population size when the population is large. So whether you put 1 million or 1 billion, it won't change the sample size. This only matters when you have a small sample. And we're going to demonstrate that in a minute. Will cluster sampling be performed? Well, we're going to talk about cluster sampling in a minute. If you're going to perform cluster sampling, you have to say yes, but if not, you say no. So if we are doing systematic sampling or just simple random sample, then we say no because those do not involve clustering. we provide a margin of error. The margin of error is half the width of a confidence interval. So in other words, how narrow do you want your confidence intervals to be when you publish your manuscript? Do you want them to, if you can live with a very wide margin of error, well, that means that you need a smaller sample size. So you put the margin of error. Typically, we use a margin of error of 5%, and then you put the anticipated response rate that you think you're going to get from your population. So in other words, if you surveyed 100 people, how many will agree to participate? So once you put those values, you click on get results, and the platform generates a number for you along with references. This is now the number that you would use. So the numbers we're using here, we have assumed that we went through that process of calculating the sample size. So just again, to reiterate, it's not just some arbitrary number. You would have to calculate that number from the platform already. If you see your hand is up, you have a question? All right. I guess
Okay,
not.
yeah.
Okay.
Yeah. No, I have a question.
Okay.
Okay, so recently we are trying to carry out a study, and we had a very small sample size, even though I sent the request to Lungile. So our sample was less than 500. So we are trying to work with community pharmacies. So now we tried using Chi-square platform, but it gave us an error, meaning that if you enter any sample less than about 700, it will not calculate the sample size. If your population is less than 700, it won't give you a sample size calculation. So my question now is, in a constrained resource setting, we don't have the money to go around the whole 320 community pharmacies. What are we supposed to do in that instance? How do we calculate the sample size?
Well, sample size is calculated not only by precision, but also by cost, right? So the whole, in field epidemiology, we place a lot of emphasis on cost-driven sample size calculation. So everything is done on the Chi-square platform is based on precision and statistics. But that's not the only thing that moves the world. The world is also moved by money and how much resources do you have. So you can also calculate sample size based on cost. So in other words, you can say, per individual, how much does it cost me to access that individual? Well, that you already have your calculation already there for you, right? So when you have small samples like that, ideally, you should not even be doing the sample size calculation. You should do a census, ideally, right?
Yeah.
But if you cannot do a census, then you should calculate it based on costs, based on how much money you have to get to these people. Because the reason why the Chi-square platform will refuse to calculate that kind of sample size is because it already violates the basic premise of samples. When we do samples, there's an assumption that the sample is infinitesimally smaller than the population. Okay. With a small sample of 500 people or 400 people, that assumption is already violated, right? So there's no mathematical basis at that point to do that. So you're better off looking at other alternatives like cost-based approaches, or better yet, take the whole census.
Okay, so now when we take the census, like most times when you submit for ethical clearance, they always want to know how you calculated your sample size. If you tell them is it total population sampling now? If you tell them it's census, most times they will turn it down and tell you to show them the sample size calculation formula that you actually use. So I don't know.
Well, that's rather bizarre. Everything in life, and especially everything in research, is based on context. So, so just rigidly applying some rule to every single context does not make any sense. But you know, but you should be able to justify that the reason why we took a census is because, well, it's a small population. So it is not every single scenario. They say to the guy with the hammer, everything is a nail, but that doesn't apply to research, right? We have to look at context because context matters.
Okay. Thank you so much.
You're welcome. All right, let's see how far we've gone here. Is there anybody who's confused about the sampling we're doing? I really hope everybody's on the same page.
Yeah. Hello, Prof.
Yes.
I just wanted to say that I've retraced my steps. I've seen the reason why it's giving me three options instead of 4.
Okay.
So just that on the second on that on the platform, on the second option, before selecting the let me just click on this second option on select sorting variables. So
Okay.
on the select unique identifier, if like I mistakenly picked zip code there, right, in that second option, then I also picked the zip code in the last one. So when I now ran the tax, that's why it now gave me those three options.
Okay.
So when
Yeah,
I went back,
you can have
so
both of them the same thing.
yeah, so that was done in an error. So I had to wanted to find out what really happened. So I had to go back and click on resample. Then I started from the beginning, select probability. Now check. I remember that you said for that one we should leave it blank. So I now remove the zip code. Then put the zip code where I'm supposed to based on the selection criteria on the last one. Then I ran it. It now gave me the actual data.
Now, after this, we're going to run it. We're going to add a validation to even prevent people from doing that, so that it's even impossible for you to select both. So we're going to add that validation.
So I just thought that let me bring it up so that someone can also do the same mistake I made.
We'll add that validation tomorrow when you come. You won't be able to do that.
So thank you so much. At least I thought to bring it up.
That's important. Yeah, thanks so much. Yeah. All right. So so what can we conclude? Why does this document keep disappearing? So what can you conclude from the estimates, the mean estimate from systematic sampling and simple random sampling? Doesn't matter so much what sampling. So the moral of the story is, doesn't matter so much what type of sampling approach you use, from what you can see. Yes or no? It's not a trick question.
No.
The estimates are close.
Yeah, it's they are samples, so of course there'll be there'll be small differences, right? But overall, as far as it's a random selection, it doesn't really matter what kind of sampling approach you use. You are going to get about the same answer every single time. And again, from here, we also see that sample size, again, who wants to complete the statement for us? The sample size has no impact on blank, but has an impact on blank.
Has no impact on validity, but has impact on precision.
Excellent. In this case, we did not calculate the confidence interval, so we can't see it. That you have to see with you can either this is the homework for you, right? You can take the estimates and calculate them later. You'll see that with a smaller sample, you have wider confidence intervals, but with a larger sample, you have very tight confidence intervals. Again, sample size does not affect validity. And that's why when people write a manuscript, you should be able to read and say, no, this makes no sense. People will say, oh, we have a very large sample size, so our results are valid. It's like, okay, that is wrong. That doesn't make any sense. Why? Because sample size has no impact on validity. It only improves precision. All right, now let's move on to stage 3 of our task, which is cluster sampling. Now we want to do cluster sampling. The first one we have to do is single stage cluster sampling with simple random selection of 5 clusters. So let's talk about what single stage selection is. In sampling, a stage is where we have to sample. So when we come to a point in time and we're not sampling, so remember that the opposite of a sample is a what? For the sake of this in this context.
Your population.
Population.
Census.
Population.
Census.
If it's not a sample, it's a census. So every stage where we are drawing the sample is a stage. So when we come to a point where we are taking the whole population or the whole census, then it's no longer a stage. So when we say single stage cluster sample, it means that in the first stage, we drew a sample, and then when we went in the second stage, we didn't draw a sample at that point. We took everybody in the selected clusters. So what we're being asked to do here is that in a single stage cluster sample, we're asked to select 5 clusters. Let's go to our Excel spreadsheet here, our Kingdom of Zamunda. So this is these are the clusters we have. There are 10 clusters: Smoleton, Tinyville, Giggleshare, Mythopolis, Snickerburg, Jumboville, Modico, Large Land, and Pinsizeburg, well, and Colossal Cove. 10 of them. We're asked to draw 5 of them at random, right? So that is the first stage, because at that stage, we're drawing things at random. There's sampling, right? So we're sampling 5 things out of 10. So that is one stage. Now, for the 5 selected clusters, when we get into those clusters, we are told to take everybody, right? We're told to, take everybody in that population and include them. So we can't, that is why it's it's no longer a stage, because it doesn't involve sampling at that point. We are taking everybody in the selected cluster. So that is no longer a stage. That's why it's called a single stage cluster sampling. I hope that makes sense. All right. So first of all, we have this Excel spreadsheet here that is called the summaries. So these are the 10 counties or local government areas or whatever we have in Zamunda. We have to, the instruction says select 5. Let's what the instruction says. With simple random selection of 5 clusters. So we have to select this 5 based at random, simple random selection. So who wants to draw a simple random selection of 5 clusters from this for us? So just copy this, save it on your computer, and upload in the Chisquares platform and select 5 at random. And let us know which 5 were selected. And then we'll then calculate the mean from those. So who wants to do that for us? Any volunteer? Okay, no volunteers. All right, I'll do it myself then. So we'll save this. These are the counties. So let's file, save as. Let's call this Zamunda counties. Not countries, counties. And so we save that. So we have them there. Then next, we've been asked to select 5 of them at random. So let's go to the Chisquares platform and select sampling, start new sample, perform probability sampling on the sampling frame. We upload our spreadsheets, which is the counties. We select sampling approach, which is simple random. We have to select 5 at random. So we're going to select 5 of the 10. You see, it already tells you the total available is 10, and our task is to select 5 of those at random. So let's click on Get Sample. So by random selection, these are the 5 counties that we have to sample: Tinyville, Snickerburg, Modico, Pinsizeburg, and Colossal Cove. Now, the instruction says we should do a single stage cluster. In the first stage, we selected 5 clusters out of 10. Now, since it's a single stage selection, we will now have to go into those clusters and select every single person. That's what makes it single stage, because it involves only one single stage of sampling, which was the first stage of selecting 5 counties out of 10. Does that make sense?
Dr. Agaku, can people still volunteer?
Okay, yes, we need volunteers now. What we need to do is we need to now put all of these data sets into one. We need to now take all the data and put it into one single spreadsheet. So to avoid confusion, let me just do that. So let's create they can volunteer for the next task so that we so let's create a new tab. Where's the new tab now that I just created? Okay, and let's call this tab let's rename this to single stage with simple random with SRS. Single stage with simple random sample of the counties. So the first one, so let's go back here. So Longile, can you please, if you can take a screenshot of this and just call out this selected counties so that I'll just select them quickly. Are you all set?
Yes.
All right, good. All right, so you just tell me which ones that were selected and I will just copy them. So what we're doing now is we're doing a complete census of each of the selected ones. So the first one is what?
Tinyville.
All right, so let's go to Tinyville. That's Tinyville, where is it? All right, right here. And again, since it's a single stage, it's a one stage cluster, we'll select everybody. Everybody selected. Again, we'll copy that and we'll go to let me just create a new sheet here outside. I will paste that there. Right. And then what's the next one?
Snickerberg.
Okay, so we'll go to Snickerberg. And again, this is a single stage cluster, so we have to select everybody. Select everybody. Let's not select the column. Let's not select the column names. So let me start from row, this actual here. So Command Shift, right and down, select everybody, and I'll paste it here. Okay. What's the next one?
Modico.
Okay, so again, it's a single stage, so we're going to select everybody. Okay, what's the next one?
Heinz Iceberg.
Okay, so select this, everybody. All right, paste that. And then what else?
Colossal Cove.
Right, so again, select Command Shift, right and down. Copy. And we select everybody. And we paste. That's the last, right?
That's correct.
Okay, so now we have to find the average. So now that we have completed our single stage cluster sampling, so we have to take the average of metabolite X. So average, select everything all the way down, close the bracket, and our value here is 40.0. Refresh this page. Okay. So single stage cluster sampling with simple random selection of 5 clusters, we got an average of 40.0 as the mean level of metabolite X. Who is not clear with that? Let's ask questions now before we move on. Who has any questions on that? And what are some of your concerns about the use of simple random sample here? Right? When we go to the counties, right? What do you notice as look at the summaries? What strikes you here as far as the sample sizes here of the variations? When we take a simple random sample, what's the implicit assumption we're making? Who can help us out here? What are we implicitly assuming?
That the samples are proportionate, whereas the size of the population actually varies.
Yeah, so we're saying that, right? Why do we need to go and sample all 10 when we can take 5? After all, they are all what? Fill in the blank.
They are all equal.
They're all comparable, right? That's what we're implicitly saying when we say, let's just take a simple random sample of these clusters. We're implicitly saying that, well, there's no need to go and take all of 10 of them. After all, they're about the same, right? So, if we know one, we know all. Is that a safe assumption?
It's not safe. It will have weighted.
Not with these
populations.
Mm-hmm. Yeah, it's not a safe assumption, right? Because there is massive heterogeneity in the samples, right? And it may not only be numerical differences, right? It may not be numerical differences. It could also be just so qualitative differences that the difference, because you have some of these are rural and some are urban, and by a simple sample, it's possible that we might end up just sampling all, counties.
That's my point.
Okay. Oh, great.
That's what I wanted to ask.
Okay, great.
That's probability of picking all the urban or picking all the rural.
Exactly.
It could happen.
You're absolutely correct. So the whole point of this exercise is also make you see how you should be able to challenge what you're reading. If you're a peer reviewer and somebody does a sample, it's not just accepting it, because the evidence is based on how it was generated. So you should be able to critique things, eloquently and say, this doesn't make sense. And if you are in the role of supervising students, you should be able to guide them to do things the right way, and you should be able to challenge them to think. So it's not just about giving instructions. Like, does this make sense to you? Like, what alternative do you think would make more sense in this context? And again, everything is contextual. What makes sense in one context may not make sense in another context. So it's not about imposing some rules that says you must do this, but it's more about being able to think and say, okay, I think that in this context, it makes sense for us to do this way, right? And we can also see that in the results. For the first time, our results have kind of veered away from the traditional, right? Here we have, again, this is not saying, we're not implying that this is statistically significant from any of this, but we see that for once, the estimates we're getting are a bit different, right? And that could be because we are favoring some kinds of clusters, that share some characteristic. Now, from the word cluster, yes, go ahead.
Sorry to cut in, but I just wanted to, even before you mentioned that, it was just running through my head. So what is, I don't know whether I'm faster now, but I'm just trying to know what is the right thing to do. Is it, for example, if I run this sample and let's say probably by the selection, let's say only urban were picked as a result, I should just run it again, because I know each time you run it, it's going to give a different selection. So is it just to leave it or to run it again, kind of?
Like you said, you are ahead of the curve. So let's finish through all of them, and then as we pick each one, we'll critique its approach, and we'll see how it affects the estimate, so you can then come to conclusion yourself. How about that?
Very well, Prof.
All right, great. All right, next we have to do a single stage cluster sampling with systematic selection of 5 clusters. Now, this is similar to the one we did earlier. The only difference is that the selection is now, we're now instructed to select 5 clusters systematically. So we need a volunteer to help us take that data, the data we had of the summaries and this data here, and systematically select 5 clusters for us that we will then use to do a single stage. So who wants to do that for us?
We have Darius.
Okay, please go ahead. So then you would tell us which 5 clusters were selected, so we can then do a single stage selection of those clusters for our average levels of metabolite X.
And also I would try to choose the equal number of rural and urban areas. So, and to have comparable sample sizes. Therefore, I would choose Shire and Metropolis for rural areas, since they have bigger sample sizes. And from urban, I think there we would also, options would be Snickerburg, Pinzensburg, and Jumboville, since they also are around the same sample size.
Okay, thank you. But you are supposed to do it with software. You don't, this is, what you did is not random selection at all. This is you just selecting by your own, with your own mind, right? This is eyeballing. So you always want to do it at random. Does that make sense?
Yes. I did it on the platform.
Okay, awesome. So which ones were selected? Let's select them.
Small thing.
Okay.
Snickerburg.
Let me highlight
Jumboville. Colossal Cove and Large Land.
Okay, so please, can you read it one more time? Small thing.
Snickerburg. Jumboville. Colossal Cove and Large Land.
Okay. And Large Land. All right. So now what we have to do is we now have to do a single stage cluster selection of all of those 5 again. So let's see how the results compares with what we did with the simple random sampling. So let's select them. Smallington. So let's find the data. Where is Smallington? So it's a single stage cluster. So that means that of the 5 clusters we've selected, we now have to go in and select everybody. So once you hear the word single stage, that means that there is a census involved. The first stage, you're going to select people at random, the clusters at random. But then when you now get into the selected clusters, you select everybody. That's what single stage means. So let's select the 5 of them. So let's create a new sheet here. So that's Smallington. And please, what's the second one?
Second one is Snickerburg.
All right, so we'll select everything here. Okay. All right, what's the next one?
Jumboville.
So select everything again. Okay, what's the next?
Colossal Cove.
All right, just a sec. So Colossal Cove. Okay. And what's the last one?
Large Land.
Okay, Large Land. Let's come here. All right, so we've completed our single stage cluster sample with systematic selection. So when you hear those terms, it should make sense to you immediately. They sound complicated, but it's nothing really complicated about them. It's as simple as it gets. It's like ABC. So so let's paste that here. And let's take the average of metabolite X. This is large land, so it's quite large, I guess. All right, so let's take the average. Let's go to the top to make sure that we're getting everything. So average, it doesn't matter where you put your cost, it can be anywhere, it doesn't matter. So equals average. Select the first all the way to the last and bracket close and enter. Our value here is 36.32. Where is this?
Inside that gets makes sense.
Okay. Then next we are asked to do a two-stage probability proportional to size cluster sampling. This is one of the most widely used sampling methodologies in field epidemiology, right? We always used two-stage PPS because the beauty of a two-stage PPS is that it gives you a self-weighting sample. So it's very favored by WHO, CDC for actual field where we need to get things really, really fast without having to worry about sophisticated weights. So this is like the gold standard in field epidemiology. On the Chisquares platform, too, that's what's implemented. Two-stage PPS with probability proportional to size. So here we are asked to, so what we'll do here is that we select, the two stages means that the first stage we select clusters with probability proportional to size. In the second stage, we select a fixed number of individuals from each cluster. So let's demonstrate that. So what we're going to do is, so it makes sense to you, this data we have here, the summary, we're going to take this data and take it into the platform and say, let's say we want to select 5, just keep it consistent. We've been selecting 5, 5, 5, so let's keep it 5. Now, here is the things you need when you want to do a two-stage PPS sampling. You must have a measure of size. PPS means probability proportional to size. So obviously, you need to have a variable that tells the platform or whichever software you're using that this is the size of the population, right? So what you're going to get is you're going to get 5 clusters that were selected. And not only that, it's going to tell us how many people we have to select from each cluster. It's going to be the exact same number of people that will be selected from each cluster. So, so somebody should please, or let me just do that so that we can share the screen with everybody. Let me do the selection. So here we want to select, just choose our sampling, the same sampling frame, I believe. No, it's different. So the Zamunda counties. So that's been uploaded. What we want to do is sampling with probability proportional to size. Select a unique identifier. We don't have to select that. Select a measure of size. You absolutely must have a measure of size, and it must be numbers. So select size, which is the only variable that fits that. Then select the number of clusters that are available. Here, we have 10 clusters available, right? We want to select 5. And why are we selecting 5? The number of clusters you select is a function of how much resources do you have to be able to go there. So this is a question of largely resources. But in the case of our demo here, we're just using 5 to maintain consistency with the other ones we selected. Ibrahim, can you kindly mute yourself, please? Ibrahim, it won't come in.
Okay.
Thank you very much. And then how many people do we need for our study based on our sample size? Well, I think we did our sample size earlier and it told us that we needed, I can't remember what we needed. Let's say 1,281 people. That's what we need for our sample size. So we put that number there, 1,281 people. Right? And then click on get sample. Ibrahim, can you kindly mute yourself, please? Thank you very much. So these are the selected counties that we have: Giggleshare, Mythopolis, Largeland, Prince-Iceberg, and Colossal Cove. It's called it's called PPS because the larger counties are more likely to be selected in the first stage. So let's look at what happens in a two-stage PPS so that we are all on the same page. So like we said, it's 2 stages. That's why we call it two-stage PPS. In the first stage, we select clusters. In the second stage, we select individuals within the clusters, right? Now, if you look at this, the probability of clusters, this is for the first stage. You have the probability of clusters being selected. And in the second stage, you have probability of individuals being selected in the clusters that were selected in the first stage. So you can see that in the first stage, we favor larger clusters. Let's look at an example. Largeland. Largeland has the size of 9,546 compared to, let's say, Mythopolis, which is just 2,800, right? And so that will be evident in their selection probabilities as well. And so in the second stage, we select a fixed number of individuals, which ensures that, individuals who are in the smaller clusters are now favored, because then the probability of selection for those individuals becomes higher. You have a problem when you have very, very, very large clusters, like Largeland. Largeland is a very large clusters. And in that case, in field, you see a probability here of cluster of 1. That is not a very good scenario to have. We call that certainty clusters or certainty PSUs. They are clusters that are so large that the software is confused and saying, well, this individual's probability is above 1. Or if we, put it more conservatively, the probability of selection is 1 for such clusters. In that case, it's no longer a probability selection, because if you have a probability of 1, that means that it's certain that you're selected. So the moral of the story here is that when you have very, very, very large clusters that are so big that the probability of them being selected is 1, then typically what we'll do is you either break them up or you treat them as a separate stratum. That's what we do in the field typically. But it is not fair to the other clusters to have an extremely large, cluster in the middle of your sampling, where you're treating it as the same as other clusters. So that is the approach we typically use in the field. We either break it up or we treat it as a separate stratum of itself. But for now, let's just go ahead with this and let's select. We've identified the 5 that we need to do, and this is a fixed number we have to select. From each of the clusters, we have to select 256 individuals, right? So let's do that and let's see how the mean levels compare. So we're going to use simple random sample to select 256 individuals from each of these counties. So we need a volunteer. We need 5 volunteers to help us draw a simple random sample of 256 individuals from Giggleshare, Mythopolis, Largeland, Prince-Iceberg, and Colossal Cove, so we can see how the results look like. So can we have volunteers for those 5? So these are the 5 counties we're looking at. So your job is to take the Excel spreadsheet that corresponds to each of those counties. So you go to, for example, Largeland, you copy all of that, save it in your Excel spreadsheet, and you go and do a simple random sample of 256 individuals because that's the number we're selecting. The number to be sampled is 256. So yes, Mohammed, you have a question.
Mohammed, you can unmute yourself.
Yeah, not a question. I just wanted to say I'm picking one.
Okay, great. Which one are you picking?
Metropolis.
Okay, great. Who wants to pick another one, please? So you understand the task, right? We're going to select 256 individuals from each of the selected ones.
Yes, I do.
All right, great. Who wants to select? Who wants to volunteer for the other ones? We need a volunteer for Giggle Share and for Large Land and all the other ones here. Irenze, which one do you want to take, please?
Large Land.
Okay, super. Again, remember you are going to select 256 individuals with random selection. So we have Metropolis and Large Land. Who else wants to volunteer?
I can take anyone.
Let me take Giggle Share.
Thank you very much. So we have Pinsizeberg and Colossal Cove remaining.
I can take Pinsizeberg.
All right, super. We have Colossal Cove remaining. No volunteers. We need one more volunteer. Do you have a volunteer for us?
Which one is left?
Colossal Cove.
Okay, let me run it.
All right, super. So when you finish your, please put your result here. Let's create a, put your result here. Two-stage PPS. Let me rename this to two-stage PPS. Two-stage PPS. So please put your results in here. So we have everybody's results in the same place. So you take the 256 individuals who were sampled, download it, then copy and paste the results in here. So we have all the results in one page.
Should we put sampling results or average?
No, we can't take the average until we have everything together. So you have to put the raw sampling results in here.
Okay.
Because that's the whole idea of a two-stage PPS. We're going to sample, and then we'll pull the results from the different clusters, and then we'll have that's now becomes our sample.
So the unique identifier is it the name? What are we using as unique identifier?
You can ignore the unique identifier.
Okay.
Prof, so the number is 250 what? 250?
256.
256, okay, thanks.
Yeah, the 256, again, remember, that's based on our sample size that we said we needed, and based on the counties, the clusters we said we wanted. So it's not a number fixed in stone. It's going to be based on what your sample size calculation is.
Sorry, how do we access the Excel sheet?
We're going to drop it the link.
Okay. Prof, done. So we have to paste it now, the link. See that first one? Okay, send it.
It's going to be here. The one with say two-stage PPS. The last, go all the way to the end.
But I don't have access to edit.
Oh, sorry. Hold on a minute. Let me change.
Even me, I don't.
I'm going to change
I
that.
don't have access.
I'll change that now. Yeah. Oops. This is all right. Change it from viewer to editor. So you are all editors now.
So you certify us as being editors.
Yes, you are editors.
Okay, Prof. We just paste it. That's one tab. So we're pasting everything.
So the first
like
person, so that we don't have confusion, right?
Yes, that's what I'm saying.
Let's do it in an orderly manner. So when you're done, so who just pasted now?
I did for pin size work.
Okay, please. So the next person who's the next person who is pasting now?
Where should I paste?
Below him.
Prof, I think you should paste it serially the way it came as well.
All right, that makes sense. That's a good suggestion. So who is Google Share?
Me.
All right, so please, can you paste your results?
Okay, that's what I want to do.
All right. The person who pasted initially, do we still have it there, or was it removed? So let's remove this completely. So hold on a minute. Let me clear the data so that we'll just have we don't double copy. All right. So please, if you can paste yours, Google Share. Where is it? So Google Share. Let's know when you're done.
I'm trying to paste.
Okay, sure.
Okay, yeah. Yeah, I just pasted.
All right, super. Let's confirm.
Let me label it.
Where did you paste it? You should paste it in single stage, the very last tab, single stage SRS.
Oh, okay. So, okay, wait. I'm sending.
Super. Now the rest of you, please don't include the headers. We don't need the headers anymore. So the next person is
Metropolis.
Please do not include the header and paste it immediately afterwards.
Okay, let me delete it.
Okay.
Let me remove the headers.
Let's know when you're done.
Okay.
You can leave your header first, the first header. That's fine.
Okay, let me copy again.
No, you'll find the way it is. You don't have to make any changes. Metropolis, who was it? Google Share. We're just waiting.
Have you seen mine?
Oh, sorry. Who are you? Are you Metropolis?
No, Google Share.
Yeah, good. Yeah, I've seen yours. Yours is perfect. You don't have to make...
Okay.
So we're just waiting on Metropolis to submit their record.
All right. Metropolis done.
Okay, done. Thanks so much. Then large land.
I think large line is done.
All right, super. And then Prince Iceberg.
Finish.
All right, then lastly, Colossal Cove.
Okay. The thing show me add more.
Okay, yeah, you can add more.
It show me add.
That's fine. You can add more rows as needed.
Yes, it's not scrolling up. Okay, it's now.
Okay.
Yeah. Is it up now? Oh, this one is not. Your access to field is updated. Reload. Okay. Asking me to reload.
You want to refresh?
I've reloaded. Let me see. I've reloaded. Let me just paste it now. Okay. Yes.
All right, super. Thanks so much. You guys
Done,
are
Prof. Yes.
All right. So now let's take the mean, the average of all of these values of the metabolites X. So here, with the value is 34.21. So let's go back and put that here. Oops. Sorry, the document is hanging. I think there's a lot of traffic on it. So 34.21. Okay. And then lastly, we have to do a stratified two-stage cluster sample. All right. This document is really struggling. All right. All right, let's just go to the Excel spreadsheet. I think that one is doing better. So stratified sampling means that we have to first of all stratify. What does stratification means? Well, stratification simply means that we are trying to create two separate, sorry, this document, I'm trying to get to the tabs at the bottom so we can illustrate. Let me just refresh this page. It's hanging. All right, great. So here, stratification means that we will have to divide the population into, I think some people added some things here. Let me delete them. Delete. So why do we stratify? Well, we stratify to make sure that we have enough people in each of the populations. Like in the case of Zamunda here, we have the rural, right? It's possible that we could do our study. The rural populations are so small. The populations of the individuals in the rural area is so small that just by chance, it's possible that we don't include people in rural. Now, that's not a good thing because we want, especially if the topic of research is very related to location. So in this case, our research question is definitely related to where you live, because we're saying, what are the factors associated with the mean levels of metabolite X? Well, it includes where you live. So we need to make sure that we account for the fact that people live in rural areas and it might be important to make sure that there's representation. So the single reason why we stratify is just to make sure that we don't just by chance omit some key population we need. To be clear, there's a lot of misconceptions about, people, when you read again papers, people will say, we stratified our data, and so that increases validity. Stratification is not done to increase validity, right? It is done to increase efficiency and to make sure that we have representation of individuals within a population of interest. So what factors should you stratify on? You must make sure that, just like we did when we're talking about systematic sampling, that the variable you sort on must be one that is very correlated with your outcome. The exact same principle here applies too. The variable you are choosing to stratify on must be correlated with your outcome. If I'm looking at the level of metabolite X, why am I stratifying on, let's say, religion? Is there any theoretical basis to argue that perhaps religion is strongly correlated with this blood level of, and maybe it's the case. Maybe people who are in a certain religion maybe ingest some particular food substances, or maybe some exposure. If we can argue clearly that religion is a strongly correlated factor with metabolite X, then of course we can stratify on religion. But if there's no reason for that, then there's no basis for it, right? We also want to be wary of having too many stratification variables, because the sample size increases exponentially by the number of strata you have, right? So you don't want to have too many strata. Let's look at an example. If we did a sample size calculation, let's go back to a sample size calculation for a survey. Let's use this example just to show you how impactful strata has. So let's say we want to say we're doing a cluster sample. The design effect is 2. For every, if we have one stratum here, that means that we're not stratifying. The sample size in this case is 2561. If we increase the number of strata by 2, that would double the sample size, right? So in this case, sample size is now 5122. If we increase the number of strata to 4, that quadruples the sample size, right? So sample size will increase exponentially as the number of strata. So you can see it's very expensive having strata in your study. So you want to keep it at the minimum. You don't want to do too much. So the bottom line is that you want to be very strategic in how you choose strata. Make sure you are stratifying on the most important variables that need to be accounted for, right? So in this case of our population here, we've chosen to make sure that we want to include people who are in the rural areas. So what do we do? When you stratify, you are entirely treating that each stratum as a completely separate population of its own, right? Once you have declared that so and so are strata, in simple terms, what you are saying is that from now henceforth, you are treating them as completely different populations. So in our study here, sorry, this document keeps hanging. So we have the guys in rural area are the ones with orange highlight. The ones in urban areas are the ones with green highlight. So the first step is to make sure you delineate which is a stratum 1 and which is stratum 2. So in this case, rural is this ones, and you define them, right? And that's step 1. Any given individual can only be in one stratum. You can't have an individual that is living in rural and living in urban. You can only be in one of those 2 strata, right? So that's rule number 1. You clearly define the strata. Then what you also need to make sure is that once you divide strata, you must sample from each stratum. You can't say, we have 10 strata, but we're going to select only 4 strata. That makes no sense. If you have 10 strata, you must sample from each of the 10. If you have 20 strata, you must sample from each of the 20. So that's why you want to be very intentional in how you select in how you divide or create strata. So here we have 2 strata, and so we must sample from each strata. And again, remember that the rule is we're going to treat each stratum as a completely different population of its own, right? And then we're going to sample, and then we're going to put them together, right? So that's the whole idea. And that's for the sake of time, we're going to leave that as homework for you. But just to go over the homework, is stratified 2-stage cluster sample, right? So try and figure out what that means and play with it. Yeah, go ahead. Is there a question?
No problem.
Okay, please, can we meet yourself if you're not speaking?
Prof?
All right. Yes, someone was asking a question.
Yes, I wanted to ask, based on what you just mentioned. So if doing stratification does I'm trying to kind of recall the exact words you use. If it's not like it's not adding, if it's not adding anything to what you're doing, there's no need doing it. So what I'm trying to relate it now to like in Nigeria, where we have 6 geopolitical zones, which is from the two main region, like the north and south. So ideally, typically, everybody in the north have the same, almost the same similarities, and when you do anything in the north, you more or less get almost the same thing. Though north central, northwest, northeast, when you want to deep down, you kind of see some kind of difference. Then when you also go to the south, south and southeast and southwest, when you dig deep again, you kind of also see some differences of some things you can dig if you really want to dig. So in that kind of instance, now somebody is doing a survey that wants to be like a national survey, for example. Will it be wise now to do it via geopolitical zone, like making a strata via geopolitical zone, which you make it 6 stratas, or to do it just via 2, like north and south? So I'm just kind of thinking in my head.
Those are questions that you have to answer as the investigator. The point is that there's no rule that says you must do it that way. However, if you're going to use geopolitical zones, you have to make sure that that is highly correlated with the outcome of research. For some outcomes, that may make perfect sense. For some outcomes, it may make no sense. So we can't exactly just make a rule that says, oh, whenever you're doing a study in Nigeria, you know what, you should always stratify by the 6 political zones. That would be a very absurd rule, right? Because everything has to be taken into context, right? The research question would drive the context that would drive how we sample. Does that make any sense? So in some cases, yeah, that would make sense. In other cases, it may not make sense. It is now left to you to use your judgment as a researcher. Of course, you also have to worry about funding, because if you have 6 strata, that means that you are increasing your sample size by a factor of 6. Can you really afford that? So it's not just about statistics, right, or methodology. You also have to worry about resources and funding and money, because money makes the world go round. So it's not an easy answer. You have to take all of these things into consideration and then make a decision. And of course, if there may be limitations, you have to note them as appropriate. But again, it's more of contextual. So that's the way you want to think of it. So try playing your hand with the stratified sample to understand what it means, and we'll go over it next class together. But I just wanted to really emphasize one last thing here about cluster samples, right? That you can see that when you compare the results from cluster sample with that from systematic and simple random sample, which results would you say have a much greater degree of variance? Is it simple random sample, or is it cluster sample? What do you say? Which has a higher degree of variance? So variance in this context means we take one sample, we get a result, we take another one, we get another result that varies so widely from the other one.
Simple random sampling.
Single stage cluster.
No, we're comparing cluster sampling in general. And
okay. It's cluster.
Cluster sample. So that's when you read that cluster sample has a lot of variance. It means that when we take repeated samples, we're going to get results that look so different from the other, right? You start wondering, like, this is results. Like, so that's why you have to be very meticulous when you are doing cluster sample, because you should know in the back of your mind that if you don't do it correctly, there'll be, you might get results that are associated with a very high degree of variance, because if you were to take another sample, you will get quite a different result, right? The same cannot be said of simple random sample, right? Because there, the results are more or less the same thing you're getting with each sample you're taking, right? So those are some of the things you want to, worry about. And the knowledge of sampling is so critical, because without this, you can't understand many, many things downstream, like what are weights? Why do we need weights, right? So that's why I decided we should just take this time today to set that foundation so that we all understand, at least, of course, this doesn't cover everything, but at least provides us some framework to speak together when we talk about sampling or issues of weight, so you can at least know where we're coming from in that context. All right, if there are any other questions, I'll take them now.
Okay. Hello, Prof.
Yeah.
I have a question. Sorry for taking you back. For the stratified sampling, when you get your strata, and you calculate the sample size, assuming you have 6 strata, and the sample size is about 500. Now, how do you know? And the strata, each of the stratum, they have their different population. Does the chi-square platform give you the number of sample to get from each of the stratum, or do you need to apply proportionate allocation?
So no platform can give you that, because you as the researcher are the one who has to decide what you are doing. So you as the researcher will decide that, oh, you know what? I want to have a fixed sample size from those two groups, right? The rural, in this case, if you go back to our data set here, in case the rural here is, where is this? Okay, so we want to sample 4,000 people from, well, let's say 2,000 people from rural, right? And urban. We want to sample 2,000 people too, right? Obviously, this is disproportionate, because in our final data set is 50-50. But in the actual population, the rural is not 50% of the whole population. So it's quite disproportionate, right? But why might we want to have it 50-50 here? Well, because statistical analysis issues are quite different from issues of sampling. When we have statistical analysis issues, we want the ideal scenario is that the two groups should be equal in sample size, right? Then we run very robust statistical analysis, which is quite different from issues of sampling. So that is the reason why we might want, we want to make sure that we have enough people in the rural, right? And we would feel that if we have 200 to 2,000, that may not work, because sample size is driven by the smaller arm. So we feel that if we run statistical analysis, we might end up with a lot of results that are not significant because of type 2 error. And so we said, you know what, we're just going to have 2,000 people here, right? So we are oversampling the rural. And so once you're oversampling, you should know automatically that, well, I have to adjust for this with weights, right? This is where you should know. So nobody should tell you that you're going to need to include weights in your data set, right? So this is where we now tie in the issue we discussed last class with sampling. You should know instinctively and immediately when weights are needed versus when weights are not needed, right? So those are minimum requirements for, like, if you're going to do research with survey data. You should know when to draw a judgment call that, no, we don't need weights here, or we need weights here, or these are the kind of weights we need here but not there, or here we need this kind of weights and those kind of weights. Those are the kind of judgment calls you should be able to make. And so there are a lot of things that we can also easily automate on the Chi-Squares platform, but they don't make scientific sense to automate them, because those are things that are inherently driven by the researcher, and the researcher should make that judgment call themselves. I hope that makes sense.
Yes, very well. Thank you so much.
You're welcome. Any other questions?
Yes, Prof.
Yes.
Okay, thank you very much. Just to draw you back a little about the sample size affecting the validity. I'm just thinking that, okay, let's assume that you are doing an RCT and you have a 2-arm RCT. You calculated your sample size. Unfortunately, you have a high attrition. and the sample size that you end up with, drop far below what you calculated. So won't that affect the validity of the study?
That's a very good question. That's an excellent question. In fact, so what we said initially was in the context of survey, again, everything is contextual, right? In the context of survey research, sample size does not affect validity because the point estimates will be the same. When we cross over to analytical epidemiology, can we please mute ourselves, please? When we cross over to analytical epidemiology, then sample size is a different issue altogether, right? Because remember that statistical power is tied with issues of sample size, right? So we have two types of errors, type 1 and type 2 error. Type 2 error is, can we please mute ourselves if you're not speaking? Can you kindly mute everyone, please? Dr. Silas, can you kindly mute yourself? Savidzem Silas. Lungile, can you just mute everyone, please?
Yes, I have.
Okay, thank you very much. So when we cross over to the realm of analytical epidemiology, it's a different thing, right? So that we have to draw that nuance. In this case, when you are doing analytic studies like case control studies or cohort studies or randomized trials, sample size in that context would affect power, which will affect type 2 error. So in other words, if you have a small sample size, you will end up declaring that no significant differences were detected. That's what we call a type 2 error. There's an actual difference in nature, but your study failed to detect it because you had small sample sizes. So again, your job as a researcher is also to know the nuances, because one thing that holds true for observational research or just descriptive epidemiology may not hold true when we cross over to analytic epidemiology, right? So those kind of nuances are the kind of things that we want to really build in our course, so that instead of having a rule of thumb, you obviously know scenarios where so and so applies, and also how do those differences play out when we switch between descriptive epidemiology versus analytic epidemiology. Any other questions, please?
Iffy. Okay. Oluwaseun. You can now mute.
Hello.
You can now unmute.
Yeah. Okay. Can you hear me?
Can you hear me? Yes, we can.
Okay. So while we're doing the two-stage PPS, yeah. So the first stage we're going to do select out of the 10 clusters, 5, and then from each of those 5, we get the list of the population, upload again online to get 256 samples. So there is a stage where it asks the second time whether are we going to put it, is it a random or PPS or systematic review, or do we repeat that PPS option twice when doing these two things, levels? I don't know if you understand my question. Because there's a place on the Chisquares platform that asks whether it is a PPS you want to do random. Do we repeat that we want to do a PPS? Hello? Hello?
Okay, Lungile, you muted me too. All right, so when you select, so no, you don't have to select it again. So again, the PPS, the PPS selection just tells you that these are the clusters you need to select, and these are the number of people you need to select in each cluster. All we're trying to do is, okay, now that we know that we have to select 256 individuals from each cluster, Okay, let's go ahead and select them. So all we're doing is in the second stage is we're uploading the spreadsheet and saying, hey, just help me select 256 people at random. So in that stage, you don't need to select the PPS. You're just selecting simple random sample. So you can select the 256 people you need.
Thank you. Thank you very much.
Okay, so I'm trying to ask my question. I'm not sure if you can hear me. Can you hear me, please?
Yes, go ahead.
Okay, all right, thank you. I don't know if you mentioned or addressed this, because I came in a bit later. I want to know the difference in this case between cluster sampling and stratified. I've always thought that they were different, but you treated them under cluster sampling. And also, if you could help define what you mean by the difference between validity and precision. I dropped this question on the chat. I'm not sure if you saw it, because you kept emphasizing that increasing sample size doesn't exactly help with validity. To increase validity, just help with precision. So what do you mean by what's the difference between the two?
Okay, so so validity has to do with the truth, right? I think I actually have a, let me see if I can pull this up. Let's see. Oh, geez. All right, let me just find. I have a good illustration, that picture that shows that clearly, but in the in the absence of time. So validity simply means truth, right? And so if you have, okay, I think I can find another equivalent. Bullseye target. I think this is a very common image. Validity. A picture is worth 1,000 words. So let's look at that. Can you see this image I'm showing here?
Yes, please.
All right, great. So validity means that we want to hit the bullseye, smack in the middle. That's the truth, right? We want to achieve the truth. We want to hit the truth. So if it touches at any point the bullseye, that means that it's valid. So, in that case, would you say this is valid? No, it's not, right? Because it doesn't touch the bullseye. Precision has to do with, another synonym for precision is reliability. Reliability means that if we do the same thing over and over and over, are we getting the same results? Think of an employee who is very unreliable. Today he comes to work at 9 a.m. Tomorrow he comes at 1 p.m. Next tomorrow he comes at 4 p.m. This guy is extremely unreliable as far as time is concerned. But the question is, does he get the job done? Getting the job done is like validity, right? Whether he comes at 9 p.m., this guy is just a terrific, he's just a beast. He always gets the job done, right? So he's valid, but he's very unreliable, because if I want to catch him, I don't know where to find him at all. But when he shows up, he does the job. So validity is the truth. Are we hitting the bullseye, right? Reliability means if we do it over and over, do we get the same results? You can repeat something and get the same wrong result every single time. Now, the result is reliable, but it's not valid, right? It's like you take a broken scale to measure your weight, and that, or if you have a dead wristwatch, every single time you look at the time, it tells you it's 11 o'clock. Oh, that watch is so reliable. It is the exact same time every single time, but it's not valid, right? So validity simply means, are we measuring the truth? Reliability or precision means like when we do it over and over and over, are we getting the same thing reliably? Does that make sense?
Yes, very much so. Thank you.
All right, great. Then the other question was about the difference between clusters and strata. Clusters, again, are, had the previous class, we explained that in detail, had a fine graphic. I'm not sure whether I can pull it up. Let me see if I can pull that up, because again, the picture is worth 1,000 words. Sampling lecture. Let's see if it's this one here. Okay, I'm not in luck. Okay, let me try one more time if I can find the lectures from last week, sampling lecture. And if I can't, well, we talked about weights last week. All right, great. So this is the screen, the slide that we're looking for. Oops. All right, can you see my screen?
Yes, please.
All right. So so these are strata. Think of strata, think of separation, think of segregation, think of things are in one box together, right? Put them separate. So in this case, we have taken all the people in the population and separated them into black and put all the black people in one box, and all the blue people in one box, and all the white people in one box, and all the yellow people in one box. This is strata. Strata means that internally, everybody within the strata looks exactly the same, right? But one strata to the other looks completely different. And we've talked at length why we stratify. It's to make sure that we have enough people. It's possible that the blue people are so few that if we didn't stratify, we will miss them out in our final sample. So what do? We say, okay, let's break them out into these different colors. The rule is once you stratify, you must sample, right? Once you break and pay. Once you break people into different groups, you must pay attention to each single stratum. So it's not enough for you to just divide into 4 strata and say, you know what, we choose to select only these 3 strata. No. Once you stratify, you must select from each stratum. That's what stratum is, and that's why we do it. So stratification significantly increases the sample. If you have 4 strata, your sample size has just increased by a factor of 4. Now, clusters are different. In the cluster, everybody in the cluster one cluster looks like the next cluster. One stratum does not look like the next stratum, right? They are very different. But here, one cluster looks like the next one. And that's the basis where we can say, well, if they're all the same, why do we have to select all 4 of them if they're all the same? Well, how about we just select 2? After all, they're all clones of each other. See, we can't say that here because each stratum is different. Once you stratify, you must select from each stratum. Here, they're all the same, so we can say, already, we have 4 clusters. How about we just take 2 of them, right? And so the whole point of using cluster sample is because we don't have money and time to select everybody, and we don't have a sampling frame. So we do cluster sampling because of efficiency. We want to cut down costs, and we want to cut down time, and we don't have a sampling frame, and so we do it that way. In the example we looked at today, the different areas, metropolis, and are all clusters, right? But we said in our homework, we're going to divide them into strata, urban areas and rural areas. So everybody in one stratum, looks the same. They're all rural people, and everybody in the other urban stratum are the same because they're all. But what you stratify on must be related to your outcome. I hope that makes sense to you.
Yes, it does. Thank you.
All right, great. Yeah. All right. Any last questions?
Hello, Doc.
Yeah.
Good afternoon. This is Abraham from Ghana. Actually, thanks very much for the insightful presentation. But because of the breakages in network, I would actually appreciate it if after the whole thing, we get a slice or the audio recording so that after the daily activities, one can sit down and then actually have a thorough draft of the whole thing. You have actually done well, but in the course of the day, we have our daily activities we are doing, and network breakages are here and there. So when it's like that, in terms of following in consistently, it's a bit of a problem. But actually, I'm actually gaining a lot. But if I get the recordings and the slides, I think I'm good to go. Thank you very much. I really appreciate you and your team.
Yeah, we share our videos on YouTube, so you can always access them. I'm sure Lungle will drop the links, so everybody can access them. And I know Lungle might want to comment more on that too.
Yes, I've been sharing the links. They're on the chat box.
Okay. I'll take two more questions after run to a meeting. So, do you have any other question? If there are.
Yeah. Hello, Prof.
Hi.
It's not related to this topic. I want to know if you have a course on decision modeling or any modeling in health economics, if you're planning to have a lecture on that.
Yeah, it's on our timetable. So we'll release that soon. So just look out for that. Yeah.
All right. Thank you.
Okay, one last question. I have a meeting to jump to.
Ogunboye, your hand is up. Dr. Gaku, when are we having the offline mode session?
Okay. All right. So we're supposed to have it today, but after last week's lecture, I just figured that we needed to have a base understanding of sampling, because you don't understand sampling, you can't understand weight, obviously. So we will just have the session next week. So where's our calendar? So yeah, we're going to have it next week and try and pick up the rest of the calendar from there. Does that work? All right. Any last questions, Lungile? Or are we all set?
Oh, thank you, Dr. Jesus. I was muted before. I couldn't unmute myself.
Okay.
So at a point I was on transit and there was problem with my network. So I want to make a clarification. There was a point you were talking about high variability with cluster sampling against simple random sampling. And you made mention of, for instance, we are stratifying maybe by a certain parameter of or characteristics, maybe by race or something like that. And okay, you were talking about rural and urban settlements or something like that. And you made mention that if we, so at that point, I was lost. Why? The question is that why should we use weight at that point? So I couldn't get that explanation. If you can please go over it again.
So we use weight whenever we have differential probabilities of selection, specifically Bayes weight, right? So we said earlier, established earlier that when the probabilities are all the same, you don't need weight. Well, if the probabilities are not the same, then you need weight. So an example of where probabilities may not be the same is where you oversample from a population. So let's say you oversample from rural population, so that in your final sample, you have 2,000 people in urban and 2,000 in rural. That assumes that they are 50-50, but they're not in the original population. So in that case, the probability of selection is higher for those in rural than in urban. So you need weights. So that's the point we're trying to make, that whenever you have differential probabilities of selection, weights are needed. Unfortunately, I have to run to a meeting in the next 2 minutes, so I have to leave. But if you have any questions, you can drop them in the chat, or you can come to. We also have a thriving community on our WhatsApp where we engage and answer as many questions as possible. So you can also join our group and drop your questions there so that other people can learn from them as well.
Yeah, just thank you, Prof. Just wanting to know if there will be a session on Prisma diagram.
We talked about this Prisma in systematic reviews, which is a different class altogether. But yeah, but Lunglake, you can drop the WhatsApp group for folks who want to join, and we can pick up further conversations from there. Fortunately, I have to run now. So, but it was nice chatting with you all, and I hope to see you next week.
God bless you. Thank you, sir.
All right, thanks. Bye.
Thank you, sir.
Thank you so much.
Thanks.
Thank you.
Thanks
Bye.
for your
Thank you.
time. You are awesome.
Thank you so much.
Sir. Thank you, sir. Thank you.
No problem.
Thank you.
Thank you, sir. Thank you, sir.
Thank you.